So we casually mentioned that Australia was not an island and India was some many million years ago, and we said continents move and so on and so forth. We can revisit that here after talking a little bit about the dinosaurs. I'm sure you all love the dinosaurs. Around 230 million years ago or so, the era of the dinosaurs began. Sometimes we say 250 million years ago, basically because when you go that far in back, it's like asking your mother and father, what happened in high school? When did you meet? And mother might say, I remember I met your father in high school on December blah blah blah, or at the prom, and father say, no, I remember something else. So when you go back in time, sometimes the timing is not exact. In all kinds of shapes and sizes, dinosaurs stomped and scampered and flew across the earth. They were flying dinosaurs until 66 million years ago, when a big meteorite fell from the skies from 250 million or so to 66 million years ago. So almost 200 million years they were just dominating the earth. They had survived for almost 165 million years ago, but that meteorite killed off most of them. But what does this have to do with climate? Well, actually much more than you would imagine. 165 million years is a long period of time. At the beginning, all the continents were attached to one another. Okay? Remember what we just said. Now you have 7 continents strewn all across the planet, and ocean covers 70% of the surface area, but you crunch them together and make one big continent, right? At the beginning, all continents were attached to one another. Together they formed one massive continent that we now call Pangea. Pan means, whole world. Gea, land. You can try to imagine where the name came from. In most places it was warm and warmer than it is now, in fact, but there were big differences in climate between the coastal areas and the land in the middle, so you're far away. If you go to a large continent, even now, like the US or Russia, let's say, Russia has only one coast, but US has 2 coasts. Coast on Pacific side is different than the Atlantic side because of which way the air flows, whether it comes from the ocean or comes from land, and in the middle it's very different as well, right? So together we had these things going on, and there were big differences in climate between the coasts and the lands. And you are looking at some schematics, that a nice animal lying here, another fossil, and some plants that are looking funny, and so on and so forth. Here is Pangea as a schematic as well. So here is Pangea. Eurasia is shown here. North America is crunched together. South America is of course together here. Africa is crashed into this land, and India is sitting somewhere there. Antarctica and Australia is not an island, and there is a nice dinosaur flying around saying, what is going on? Right? At the edges of Pangea it was damp. That was because these areas bordered on the oceans where the rain came from, and the land in the middle of the continent was much drier. It had a desert climate. The rain hardly ever came that far. It was like the middle of Australia, which is now a desert. Also, in the center it was ice cold at night and in the winter, but extremely hot in the daytime and the summer, which also happens in the deserts at present. When we say land was here, land was there in the past, maybe you're old enough to say, how do you know? So you have to say how old, let's say, a rock on Australia is, and then you have to say where it was at that time. So we use multiple detective techniques to do that. There are magnetic lines which can tell us whether it was near the equator or far away from the equator. The magnetic lines in the rocks will be different here than here when Australia moves closer to the equator. And we can take old rocks and we can use something called carbon dating, which can go to some 50,000 years, or some other isotope. If you don't know what that is, don't worry about it. There is lead and this and that, and they can tell us how many millions of years, how many billions of years old a rock is, and so on. Okay, it's a nice detective work. Maybe someday you'll grow up and become a geologist and figure all these things as well. Okay, so we had cold deserts in the middle, because sorry, where was I got lost. Closer to the sea, these differences were not as extreme. That's because water cools down and warms up more slowly compared to land. So land can warm up fast during the day when sun comes up, and can cool down fast and the sun goes down, but the ocean warms up slowly and cools down slowly. So you get maritime weather, which means it's very mild in terms of how quickly it changes. Okay, and the temperature of the sea has a lot of influence on coastal regions, because if it's warm it puts a lot of moisture, if it's cold it makes things drier. You can see this in the cities like Seattle or Vancouver. Their position by the sea means they often have a kind of patchy winters, while it's absolutely freezing in Chicago and Calgary and Toronto. But if you're in Europe, you can imagine another inland city and coastal place like the UK or Spain and Portugal. Very different weathers, right? But Pangea did not remain whole. This enormous region broke apart into different pieces. Eventually the continents drifted away from one another to form the world map that we know today. That meant there were lots more regions that bordered the sea. Climate became wetter and differences in temperatures grew smaller and smaller. Even at the North Pole it was hotter than it is now in Canada and Great Britain. This meant that the dinosaurs were able to conquer the whole world from North Pole to South Pole and everything in between, and they managed to do it all without any fur coats. We don't know any dinosaur with a fur coat, so they were wandering around happily like they were on a beach all the way to the poles. So how do continents move? Imagine like a jigsaw puzzle that is floating on honey or molasses or water. It's just bobbing around and moving around. Sometimes they come together and form one Pangea, and then they break apart and go away. When it was first proposed in the 1900s, 1912, a nice guy called Alfred Wegener, who was a meteorologist and a geologist, said, "Continents move," and people thought he was crazy, and poor guy died before technology could be used to show that he was actually right. He sounded crazy when he said it, but he was actually right. But as you know, 66 million years ago, coming back to dinosaurs, the dinosaurs died out. Most scientists think this was because an enormous rock from space that fell to Earth created havoc in Mexico. You can find the Chicxulub crater, I don't know how it's pronounced, which is 150 kilometers in diameter, bigger than New Jersey. It must have been formed by a meteorite with a diameter of at least 10 kilometers. When a meteorite crashes into the earth, it will break the continent and leave a big crater. There are many crater lakes where meteorite crashed and the water filled in, and so on and so forth, right? It must have been formed by a meteorite with a diameter of at least 10 kilometers. You may think it's small, but if it 10-kilometer large object crashes through the atmosphere, it will set fires. When it crashes, it will throw up water, create volcanoes, because land will break into pieces, dust, and so on and so forth. Okay, the dinosaurs didn't die because that huge rock fell on their heads, though, well, except for a few dinosaurs who probably were in its path. But maybe they were the lucky ones who died quickly. At least they didn't have to suffer the terrible consequences of the impact. They just got crushed like a bug quickly, because you could certainly say that the meteorite kicked up a whole lot of dust for years. The sun was completely darkened by the dust. This caused problems for plants and algae who need sunlight to survive. A lot of plants died, and so the plant-eating dinosaurs died as well. And then the meat-eating dinosaurs had finished off the last plant-eating dinosaur. There was not much left for them to eat either. The rumbling stomachs and the last dinosaurs met their sad and sorry end. But there may be more details. When you throw up so much dust and everything, you probably also create a lot of diseases, viruses, bacteria. So the impact of the meteorite most likely caused big forest fires as well. Those fires killed off many trees, releasing a lot of CO2 into the air. You already know that what that means: extra greenhouse gases and therefore extra heat. That wouldn't have made it any easier for the weakened dinosaurs to survive past this episode. There was also an unstoppable volcanic eruption in India at the time. The lava went on bubbling out for millions of years until there was a layer 2 kilometers thick, converting the area roughly the size of Texas into this igneous rock, the delta. The volcano pumped it's called the Deccan Plateau, the volcano pumped a huge load of CO2 and dust again into the air. The dust darkened the sun, and which at first made it colder for a few years, and then the plants died, but then later it became warmer because of the CO2 from the volcano, and the dead plants rotting and releasing methane and CO2 as well. So you have these cycles of meteorite crash, land getting crushed and moved, volcanoes erupting, CO2, plants dying, and so on and so forth. So you can see that there are lots of things that have an influence on the climate. A changing map of the world can make it wetter or drier. Mountains can come up and sink. Meteorites, forest fires, and volcanoes put extra CO2 and extra dust in the air. The CO2 warms the earth and the dust cools the earth because sunlight is unable to get through this thick dust layer, but also causes plants to die, and so extra CO2 is released again when organic matter rots and becomes carbon and oxygen again. The last of the dinosaurs got to see all of that for themselves as they struggled through this horrible period. They were confronted with major natural disasters. All those disasters had an impact on the climate at the time, and the climate had a disastrous effect on the dinosaurs and wiped them out. Then we had a few farts from the sea along the way, and we started having erratic mammals and mammoths coming about doing their thing. We'll come back and discuss. Okay, I hope this is fun. This is so much fun, you know, all this detective work scientists do for us and put together this story, and we learn so much about climate, about life, about earth, geology, chemistry, physics, maths, and so on, biology as well, right? See you in the next podcast.